Okay, hi, I'm Harrie. I've been a PHP developer for almost a decade now. Last year I switched jobs. I now work for a back shop in the Netherlands. It's a web shop. I also have a Twitter account, which you can see here. I'm from Goes in the Netherlands, which is there. So it's not really that far, you know. It's just like there's a bit of water in between. But besides that, I like to think we're practically neighbors, right? And as I said, I work at Backshop. So we are an e-commerce website. We're selling equipment for stages, studios, musicians, DJs, that kind of stuff. Until now, the website is in Dutch, so we are actually shipping to the UK. But if you wanted to order something, you would have to learn Dutch first. So I'm sure eventually there will be an English version as well. But for now, this is it. And I'm going to talk to you about unit testing today. I'm first going to explain to you why unit testing is important and why you should do it. Let me ask you, who of you has ever written unit tests? Any hands? Okay, so this talk is really meant as like an introduction to people who haven't written unit tests much, so I don't know if this will be too simple for you guys or boring, but whatever, if you wanted just to see if you're doing the right thing, then of course you're welcome to stay. Who of you has never written unit tests before? Also quite a lot. Who of you has been planning to start writing unit tests but never got around to doing it? Yeah, a lot of hands. And I was hoping for that. That happens a lot, right? And that was kind of why I decided I wanted to do a hands-on presentation, so me actually writing some unit tests for you guys, so you can actually see how it works in practice, and hopefully that will help you getting started when you're back working on your own project. So I'm first going to explain why unit testing is important. Then we're going to write a really simple school book example unit test. I'm going to explain something about writing testable code and why it's important, how you could do that. I have some things I placed under the chapter Voodoo, which are things you probably shouldn't do, but they are damn handy, so you probably would like to do them anyway. Test-driven development, I want to explain what it is and why it's important, and then I want to tell you what to test. So first, why is unit testing important? Well, first of all, for something I like to call the balloon effect. In software, it's really common that you fix a problem at one place and you test that, and that's fixed, you know, and you put it in a repository and you think you're done. But then that change suddenly happens to break something else, somewhere else in your code, you know. So you go there and you go fix that, and then that's fixed, but then the other thing is broken again, you know, and you keep like running around all the time. So just testing what you just built or changed doesn't always cut it. In an ideal situation, you would like to test your entire application every time. After every change, you want to test everything. Is everything still working the way it is? And doing that manually is like a lot of work, if not impossible, you know. I mean, imagine after every bug fix, you would have to test your entire application that you're working on. Is everything still working? Is everything still there? So you're not going to do that. And it's important to have a tool for you that can do that. And PHPUnit is a tool that will do that for you if you write your unit tests. Another reason, this is the cost of change curve, well, or my interpretation of it. But what this says is that the earlier that problems are found in your software, the cheaper they are to fix. Now, this is really an old concept, going back to, I think, the 70s or something like that. And what it basically says is that when you're in your functional design stage and you find a flaw in the design, it's still relatively easy to fix, right? You can just like change a couple of lines in the functional design, maybe upload another graph, and you're good to go. If you discover it in the technical design, it takes a little bit more time to fix the problem because you have to go back to the functional design, change that as well, think about technical solution as well, but it's still relatively cheap. If you're in development, it's already a bit more expensive to change, and so on. If we're in an acceptance test and we discover a problem, that might be quite a lot of work, right? If somebody says, well, this isn't what I ordered, I want to work as differently, or you find a bug or something else, you will have to go back into your code, investigate what was I doing here. It's not in your head anymore, so you have to read up on it, and so on. And even worse in production, of course, right? If something's in production, if something in production is wrong, it takes a lot of time and a lot of costs to fix it. Now, this graph, as I said, goes back quite a long way, and you can imagine back in the days when we were distributing software on CDs or stuff like that, you would actually have to send out a new CD or whatever, you know, with the software, so that was expensive. And nowadays, with the web and with the modern technology development methodologies like Agile and stuff like that, it maybe not this literal anymore, but still a lot of it's still true, you know. The sooner you find a bug, the easier it is to fix and the less costs you have. So that's why it's important. So check, we've seen that. Now let's go write the first unit test. This is the first time I'm going to do live coding on stage, and I was always told that this will blow up in my face sometimes, so but it will fun for you guys to see as well, you know. Oh, I'm using PHPUnit to run my unit tests. I think it's the most popular tool to run unit tests at the moment. You can find it at phpunit.de. And this is the link to the manual, of course, that's also on the website. The documentation is very thorough and well structured, so it's really easy to find things. And so if you start unit testing, if I write unit tests, I always have this like in the background window somewhere to pop up whenever I need to know something or want to look something up. Installing PHPUnit, I leave up to you. There are 3 methods. You can upload, you can use Pair, you can use Composer, or you can download the VAR archive. It's all very well documented, and I trust you all with that you can manage that right. It's like typing 3 lines of code or something in your command line, and then you have it. So that's rather easy. So let's write the first unit test. There we go. Again, if you can't read this, move closer. Okay, so this is the method we want to test, right? We want to write the unit test for this. Of course, it's a very easy method, but I always like to write a unit test for some method like this in my project, just to be sure that I've got everything set up properly, you know, so that PHPUnit is running and etc. If this is my project, I can create a folder unit tests in it. And what you see is that I placed 2 files in here. You can't read this, right? I'm sorry about that, but I didn't know how to get the left column larger. But this is phpunit.xml. It's in the unit tests directory. And what I'm telling here is that there's a test suite. A test suite is a way of grouping tests together so that you can later on run certain tests or all together, you know, but you can decide to only run tests on a certain subsystem or only the smoke test, the really important tests, and leave the big test for everything in a separate test suite, something like that. In this case, I'm declaring just one suite, which is called SRC. That's the name of our test suite, and the directory where the tests reside in is called SRC. So that's the directory over here. That's the directory in our unit tests directory. You can also see a reference here to bootstrap.php. And this is the file that PHPUnit will include before starting to run any tests. So you can use bootstrap.php, for example, to if you're using Send Framework, to include Send Framework to get the autoloader running, to get the database connections working, stuff like that, you know. Same for other frameworks, of course. In this case, the only thing I'm interested in is, I'm using Composer in this case, is the Composer autoloader. So in this case, this is what my bootstrap.php looks like. It isn't very complicated, but it does get my autoloader and it makes sure that I can get my classes that I want from my tests. Now we get to the real fun bit and actually writing a unit test. Now, as I said, we defined the test suite to be in the SRC directory, and basically how you organize everything in that folder. Let me see if I can that's working, yes. See? What I tend to do is keep the structure of the directories the same as in my project. So if in my project I have a folder models, I tend to also have that in my unit tests folder. Now this isn't a requirement from PHPUnit. It will just scan all the directories, and every file ending on test.php it will see as a unit test, so it will start running that. But just for my own sake, that I can find back the tests that belong to the certain pieces of code, I try to organize it the same way. So in my project, the folder is called Harrie. Oh, Harrie is my nickname, right? I mean, my first name is Harrie, so it sounds the same. Yeah. And then there I have a folder called model, and therein I have my model classes. So I do the same in my unit tests. So if I'm going to add a test here because my file was named simple, so I'm just going to call this simple. Let me put it simple test. There we are, and we start typing our test. I'm not cheating by looking at this paper at all. So I create a class and I extend it from PHPUnit framework test case. Now you can also put like a class in between there where you have like logic specifically for your project or whatever. In this case, I'm just going for the direct inheritance from PHPUnit framework test case. And I'm going to write our tests. So public test double. PHPUnit will start looking for methods starting with the word test and will execute every one of them as a test. So I already regret using namespaces. The result is simple object double 2. So what I'm doing here is I create a new object of the class I wanted to test, where the method is in, right? And I'm simply calling the method. So I'm simply calling double 2. Now all we need is to validate that the result that we're getting back is actually makes sense. So we say this assert equals. It first says expected, so the expected result where we use 2 as an input. So I expected the double to be 4. And then we have the actual value, so we say result. Then I can add another line to it, which is the message, which will be shown if something's wrong with it. So we can say, we expect the double value of, oh, that's interesting. The double value of 2 to be 4. And that's it. Now if I can run this, so I go to my unit tests directory. This is where my Bootstrap and my PHPUnit.xml are, right? If I would now run PHPUnit just like that, I would run all the test cases, but there are already some test cases in there for later on. So for now, I just want to run the one I just wrote. So I can also provide it with a path. So I can say run this unit test. And when I run it, we see a little dot over there, which means pass. So for every test that's passed, a dot will show up. The reason being that if you have like 150 unit tests, you don't want it to be too verbose. You don't care about everything that's passing. Only when it fails, you want some more information. So just to prove that this is working, I will now make a mistake. You know, later on somebody else comes in and no, this isn't right. This isn't double. It should be like this. That's the way how we do this. If we now run our unit test, let me just clear this. We have a failure, and we see that first our own message. So it says we expect the double value of 2 to be 4, and then we get the message that PHPUnit automatically generates for us. So it says failed asserting that 3 matches the expected 4. So in this case, we tested the method, right? Well, that's basically all there's to unit testing, so thank you for coming. You can add more test methods in here, right? So as many methods as you want. Everything that starts with test will be executed. And there are 2 special methods. You have the method public function set up. which you can override, and there's a public function tear down that you can override. And what these will do is they will get executed, setup will be executed before every test, and tear down will be called after every test. So if you have like 4 tests in here, it will always first run setup, then the test, then tear down, then setup, then the next test, and so on. So you can use this to like set up an object, test it in a certain way, set everything back the way it was, create it again, run some other tests on it, and so on. In this case, I'm not really going into that because it's more useful for really somewhat bigger test cases. But it's useful to know that they're there. Someday you'll be needing them and then you'll be happy that they're there. So just keep those in mind. So testing this was easy, right? Yay. I mean, anyone here who wouldn't be able to write the test that I just wrote? No, right? It's just a couple of lines. You call a method, you check if it's double correct. But the problem is our code doesn't look like this. Our code looks like this, right? And it's a lot harder to test. And this is, I think, where a lot of people stop bothering, you know? I mean, they go back home and they start writing unit tests and they say, well, I don't know. I can call this method, but it's doing stuff to the database. It's emailing my mother. I don't know what it's all doing, but I'm not going to call this just from a command line script, you know? So unit testing is hard, and people stop and they stop caring about that. So we now know how to write simple unit tests, check. But how do we write more complex unit tests for real-life code? Well, basically it's the same, but it comes all about writing testable code and making the code that you just saw easier to test. So, of course, in the first place, you would break it down into smaller pieces because smaller methods will be easier to call and test and to see if they're doing what they are doing. But it's also important to isolate your code, and this is really the essence of unit testing. Imagine we have a model something like this, you know. We have 2 controllers calling a model, and this model is doing some stuff that involves a database table and some mailer object that probably sends emails. The problem is if we imagine we want to test something in this person model that's in the middle of the screen. So what we do, we don't call them from the controller, but we have our test case immediately, oh there he is, calling our model. This is what we just saw in the simple test, right? We simply called our object from the test instead from anywhere else. But if we're doing this, we still are hitting all those objects that are below there. All those classes are getting called as well. And if there is a call to email my mother in there, it will be called, as she will get an email every time I run unit tests. So what we should do is replace all those classes around it that aren't that we don't want to test. We aren't interested in this test case. So we replace the mailer by a mock mailer, and a mock object is a copy of the mailer object. So it's basically the same object, except for all the logic has been stripped out. So it has the same API, it has the same methods, but when we call them, it simply does nothing and returns a predictable value that we can all like understand. So for example, if we have a method send mail, we can replace that by something that simply says return true. Because we're not interested in this mailer object right now. We're testing our model and we want to know if our person model is doing what it should be doing. And in this case, we can say, does the person model respond in the right way if the mailer send mail function would return true? Right? It's a given. So we can, and maybe in another test, we want to check, does it respond good as well if it returns false? So yeah, that's basically what it comes down to. And we do the same for all the other objects. And now we have our model isolated and we can test the crap out of this and we don't have to worry that all other things are going on. We can just call it over and over again and see if it's working. That doesn't mean that we aren't going to write any tests for our mailer object. That might be another test and then we do the same but for the mailer object. And then we would get rid of the person model and whatever the mailer object is involved in. And we would just try to isolate that code and test that. So how do we do that in practice? let's go back to the code. So I've got a class here, which is my user model. It takes a first name and a last name, and I'm interested now in testing this method. I want to know if this send message received mail method is really doing what it's supposed to do. So it gets a mailer object, it combines the name or something, it says then mailer sent, and that's it. Now, of course, I could just write a test for that like this. You can do this to have PHPUnit skip tests, but I'm now stopping to skip it, so there we go. So I can say user model is new user model with some parameters. You can't see them, but believe me, they're there. Then I call the send message received mail with some parameters, and then I say this assert true result. I want to check if the result is true that it returned. Now, if I would do this, it would actually start sending out emails, right? Because that's what the method does. It sends out emails to the person that I provided it with. Now, the classic way to solve this, and I don't recommend that you should do it like this, but I like to show it because it's really the way it's really what's happening under the bonnet. So it will help you understand what PHPUnit is doing later on. In ye olde days, we would make another class. We say class mockmailer extends bloody namespaces. Harrie lib mailer. There we go. And then we would simply override the existing method. So we would say send, and it takes an email and a name and a subject and a body. And I would simply say return true. Now, there's only one thing we have to do, and that's making sure that our user model is now using this mailer class instead of its default. Luckily, hint, my user model has a method called setMailer that I can provide with a mailer object. And now all of a sudden, it isn't using the send method anymore. So if we can go back to the original code, this mailer object is now my mock mailer, right? So this send method isn't actually going to send anything, it's simply going to return true. And I can now test this method without worrying that anything bad is going to happen. So that's how we used to do it. Shall we run this just to see if it's running? Let's. Okay. I'll just run PHPUnit. You will see some. Wow. So the S's are skipped tests. Those are, I have marked those as skipped because I haven't gotten around of showing them to you yet, so it just has skipped in there. Apparently I made an error somewhere. This is the part where things blow up in my face. Let's see if I can figure out. Oh, yes, of course. Right, I forgot to install. It's pretty important that you get an object from your class. Let's call it again. Yay, we're good. So now I have, first I had an error, now we see it's passing. So yeah, we know this is working. Now if for some reason this wouldn't return true anymore, of course it would now fail. Okay, failed. It expected true to be returned, but it is false. Now there is a problem with this test, and that is that it isn't really a very useful test. I mean, we're actually testing nothing here except for that the method is returned true. If we wanted to do something more with that, oh, sorry, I'll get to that later on. So this is how we would use to do that, but luckily PHPUnit has an interface to do this for us, because you can imagine with all these mock classes, they can get quite a lot of them for different test cases, for different code, etc. So what we can do in PHPUnit is get rid of all this. And instead of creating a mail like that, we can say, it's on my next page. We can say this get mock, the original class name, so that's because I'm using namespaces, this whole story. And then I can pass it with an array of methods we want to mock. So in this case, I say I want a mock object of my mailer class, and I want the send method to be replaced by something void, it's not doing anything. If you don't pass the second parameter, so you don't pass any arguments to that, it will mock all the methods in the class. So all the methods will return void. Then I can actually mock our method, because our method should return true, right? We were expecting that. So we can say mailer expects this once. So this says we expect the mailer to be called one time, this method to be called one time only. The method is called send, and it will. This is a syntax you have to get used to, but after a while it feels kind of fluent, I mean, it's just like you can almost read this. It's just like English. So there we are, and in this case we have an object created, and we have a method send that will return a value true when we run it. Now, just to prove this, I'll run the unit test again. Let's hope this works. There it was, Harrie model, and it was called user test. There, it passes. It's working. Now, of course, this isn't a really useful test, because we're just testing if this is returning true, which is maybe not really that relevant to know. But what might be relevant is, for example, if this first parameter is something we were expecting. So what we could do, we can extend this with, and we can say this equal to, and then whatever email address we pass to it. So that's johndoe@mydomain. And you can define a second one after that, and so on. So now you can check if the send method is called with the right parameters. So one of the problems with that, or if you would try this on your own code, is that you might find that you cannot assign this mock object to your model, because it's created in the model itself, right? So if, for example, I have code like this, and I'm creating a tag in my constructor, this is a really weird example as it is, because I'm passing like my speaker's name and my tag title to the same object, so I don't know what kind of object this is. But the problem here is the new keyword, right? As soon as you see a new keyword, you know one thing, and that's those objects are tightly coupled. We can never have a speaker now without that exact tag object. And we don't want that. In this case, we just want to test the logic in our speaker class and not in our talk class, because that's what I explained earlier. So in order to do that, you should rewrite your code so that it does accept objects to be set from outside. So it doesn't need to be hard. This is already called dependency injection, although a really simple form of it probably, a constructor injection, where you can actually pass the tag object to the object through the constructor. So now we can suddenly write a test for it, right? We can make a mock tag object and assign that to our speaker, and then we're good to go again. Or you can use a setter, of course, so you can just have a set tag or something like that. You can even have nowadays you see dependency injection containers that create all kinds of dependencies for you. So I here now still have the same static method, create a speaker with a tag, and it will create a tag object for me and create a speaker object for me and attach them together. And nowadays, I think most modern frameworks have ways of implicitly saying which objects are connected together through XML files, for example. So you could just define in an XML file a speaker object has a property tag, and that would work. There are several solutions for that. But anyway, it's important that those classes, whatever you do, aren't tightly coupled, because as soon as they're tightly coupled, you can't test them individually anymore. You have to test them together. And you don't want that. You want to test the smallest amount of code that makes sense without like the whole Christmas tree that comes behind it. So to illustrate that, I've got another test lined up. So imagine we would like to test this method here at the top. Get number of fruits. For some reason we have fruits in our database and we want to test how many, I don't know, apples we got. That's really hard to do, right? Because if we would call this, we wouldn't know what to expect because we don't know what's in our database. So we don't know what it will be returning. Are it 4 apples, 2 apples? I don't know what to expect what's there. So you would like to replace the database query object. But in this case, you can't because it's just created there. If I call this, it's always going to create a new database query object and it's always going to call that. So really the reason just how you can solve this, how I like to solve this, like the easy way, is just by making something like a new database query into a getter. So I could say protected function get or create database query. I know this isn't very fancy, but if you're just like in the middle of coding and you just want to test it, it gets the job done, right? I didn't really change anything except for now I can maybe mock this method and have it return my mock database query, or even better, if we're here anyway, we could say protected database query. Well, you get the point, right? Return. This is something that already would work, right? Now from my test, I could just create a mock object for my database query, assign that to my object, and then that would be used instead of the real database connection. And then I could mock like things like set table, set like, get results, etc., and run the tests just like I did with the previous test. Does that make sense? Everybody sleep? Good. So when it comes down to writing testable code, it's important to write small methods to keep the complexity low and to have no tight coupling. And that's not actually a bad thing, right? I mean, when you think about it, that's actually also, those are all like solutions for code smells and stuff like that. So this really are good things, and so it isn't a bad thing that you have to rewrite maybe some of your legacy code to make it testable, because in fact it will probably make your code actually better and easier to understand and less tightly coupled, so you could reuse it in other places maybe and stuff like that. So that's a good thing. So writing testable code, check, we've seen that. What's left is some Voodoo. And stuff you probably shouldn't do, but it is damn handy. And the first of all I got from a blog from Sebastian Bergman. It's called Testing Your Privates. Pun intended, no doubt. And it's basically about calling protected methods and private methods to test them. So what he's basically doing, if we get to our fruit object again, oh, here we are. I'll just revert this for now, blah, 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 blah. I'll mark this as skipped for, oh, no, never mind. We have a method here, get the number of fruits by color. And it's very inefficient, bad code, I know, but I couldn't come up with a better example at that time. So we want to know all the yellow fruits. So we're doing all kinds of things and fetching stuff from the database and then looping through it and adding a counter, etc. And here we're calling a method, this get fruit color, and we pass the color name. So we apparently have a method that's getting the color. And in this case, we're actually only interested in testing that method. So we're interested in testing this. Get fruit color. Okay, so normally you wouldn't be able to test this, right? Because it's protected, and if I created an instance of the object, I wouldn't be able to call it. There is a trick, however. I don't say it's nice, there is a trick. And it's this. So you can use the reflection logic of PHP to get a reflection method object. You can say set accessible is true. Then get the color by calling the method. So in this case, I'm calling the method get fruit color, and I'm passing it a variable banana. And then we can assert it. So we can say, okay, we expect bananas to be yellow. Now, of course, I'm sorry this is going a bit fast. There's a link in the slides to the blog of Sebastian where he's explaining this in more detail and where you can reuse it from. And this is actually working. So just to show this one more time. I'm running the wrong one. Let's run them all. Get through, and we found a bug. A unit test delivered something. We expected bananas to be yellow, but blue isn't equal to yellow. So as you all noticed, it says blue here, and that's incorrect, right? So yellow. Let's try it again. Yeah, we're good. Everything's passed. Okay. So we fixed the bug as well. There is a side note to this, however, and it's a whole story. I'm not going to read it for you, but this is a quote from Sebastian Bergman, who's quoting Dave Thomas and Andy Hunt. But basically what they're saying is, and I really like the last line, where that it might be a warning sign if you find the need to test private or protected method, it may very well be a warning sign that there's actually another class in there struggling to get out, as they now call it here. So there's probably something wrong with the way you set up your object and the way your code works. However, I found on multiple occasions that this is very handy. So yeah, if you want to know more about it, there's a little link here on the slides. I'll put them up on Joined In later on, and you can read all about it. A question I often get is, how do I test the database? People ask me, because they are like testing their code and they're wondering how to do that. Well, short answer is you don't, in my humble opinion. Simply because you're isolating every object and you're testing those. It doesn't make any sense to have a test database and get data from there, put data in there, because your logic actually shouldn't any time get to that point where they get to the database. It should be abstracted before that. However, apparently there are some situations where you can't really avoid it, like when you're using some software or whatever that will just randomly start getting stuff from the database without asking. And there are solutions like setting up an empty database and then inserting it with predefined data sets and running tests on that, so getting the data and seeing if it's behaving correctly. Luckily, I've never been in the position that I needed to use this, so I don't know too much about it. But if you want to read more about it, you can go to this URL in the manual, or just go to the manual and click database. And there you can read more about it. So that's the Voodoo part of the talk. 5 minutes for 2 chapters left. That's interesting. No, it will be fine. So test-driven development is something that's widely regarded as a good idea. And it basically comes down to writing your tests before you change your code. So instead of first writing your code and then finally at the end writing a test, it's a good idea to actually start by writing tests. So you can do, I found that the easiest way to start doing this is by fixing bugs or by changing existing code, because it basically entails you writing a unit test that fails and proves the bug. So there's a problem, you know, so you write a unit test that fails because of that bug. Then you start fixing it, and you know that it's fixed once the unit test turns out green. Now immediately you have like a proper unit test that tests your code, and you can also be sure that the bug isn't coming back, because as soon as it comes back, the unit test will point it out again. So it's a good idea. It's a bit more tricky when writing new code, especially when you're new to unit testing, but it is something that you could try to do, because if you like designing a new class or multiple classes, and you write your tests before you actually write your classes, you get a really good. You are forced to think about how they should work and interact and how their interfaces should look like, etc. So that's a good thing. So it isn't easy to do test-driven development when you're just starting off writing tests, but try to do it, if not directly, on the long run maybe. And then there's the question of what to test. And I think that's different for everybody, right? I mean, I'd say important business logic, stuff that's likely to go wrong, complex functionality. In the ideal situation, everybody would test 100% of their code in unit tests all the time. But we all know that time unlimited on projects is it's often limited on projects. So it really depends. I'd always go for the most important business logic first, right? I mean, if you have a web shop, the checkout process is probably pretty important and you want to cover that. Some calculations for discounts. The displaying of some product page maybe might be less interesting, you know. Maybe not the first thing you write unit tests for, but maybe later on. So it's really up to you to decide. Another tool that you could use is look at the CREP index. I can actually show that if you. I'm still like glancing in my eye corners if I have time. What we can do is run PHPUnit and pass it with a coverage HTML parameter. So we say, okay, generate some code coverage HTML reporting into this directory. Now it will run our unit tests again, and it will generate some HTML afterwards. If we now look at that, and look at there's a nice bookmark to it. There are several things going on. So in our model, we can see what code is actually tested. So in this case, we see, okay, this is hit, this is tested. The tests that I wrote passed all the green lines, right? So they hit all the green lines while the tests were running. The red lines are never touched during the test, so we probably need to write some tests for those. But what's more important in this case is the CREP index, which stands for Change Risk Anti-Patterns Index. I love how they came up with that. And it basically is a number saying how complex your method is, or to be more specific, it takes the cyclomatic complexity of your method, so that's really how complex it is, and then it takes into account the unit tests that you've written for it. So you can bring down this CREP index by writing unit tests. So if you're not sure what to write unit tests for first, or what's in desperate need of unit tests, you could run just this report and just see which methods are in need of most attention, right? I don't know if I have any good example. I haven't run anything unit tests here yet. So this one has a CREP index of 12, so that's rather high. I have a for each if statement in there, so there's some complexity in there. I haven't written a single unit test on it yet, so this is probably a candidate to write a unit test for. So there we go. In conclusion, write testable code, so keep your code short, your method short and simple, and avoid tight coupling. Isolate the code you want to test, so only test that piece of code and test the other piece of code in another test. Try to apply test-driven development and start writing tests tomorrow. Thank you.
Thanks.
I believe there are still time for questions.
Yeah, so any questions?
Yep.
Hello. Going back to the banana example that you asserted that bananas are yellow.
Yes.
How would you make sure that that test was complete? I.e., if you had asserted that apples were red, it would have passed. If you see what I mean?
So you mean if you would have multiple assertions in the same test?
Yeah. Yeah. Is that a suggested solution? Yeah. I would also. It's not on the coverage report. Is that because it was reflected?
Or maybe I still marked it as. It wasn't. That's interesting. Oh yeah, here it is on the coverage report. So in this case, yeah. So in this case, we only hit like the banana case, and the other cases we haven't hit yet, right? So if we would fix that, we there we go. We could. Well, in this case, because of all the reflection stuff, it's a bit. I would have to do the entire thing again, probably.
That's fine.
Or at least.
Sorry, yes, it's fine to say that the answer is that you would put multiple assertions in the same
So
text.
yeah, so you would do something like this and say, red, I'm determined to get this working, and then apple, we expect apples to be, no, that doesn't make sense, red. Well, they can be yellow. It's probably, will it work? Yeah, so there we go. See, and now that one is covered as well, so you can have multiple insertions. It is important to mention that if a test fails, it will automatically continue with the next test in your class. If an assertion fails, so in this case, the first assertion fails, so bananas don't turn out to be yellow, it will stop the that test completely. So it won't assert the apples clause anymore until you first fix the bananas thing. Does that make sense? Yeah. Oh, you're just yawning? Or?
Yeah, it's quite interesting. Just one thing that I kind of disagreed a little bit with was when you said about the database connection, you just mock it all.
Yeah.
And I think really sometimes you should be really testing real world situations. So you should be testing the ORM layer if you've got one and the database, and you should put all that set up in place to make sure that works. Now, obviously, you have to have the same environments, etc. But that's something I kind of thought, I understand you're testing just your code, but, in a real world situation, it's quite a bit more.
Exactly. I would almost say that if you're really worried about your database being like not tested, that you could write like separate tests just for the database to see if certain columns that you expect are there or if they're matching with a certain schema. I don't know. I'm not too fond of testing my database. Then again,
I must admit.
If you want to have like tests for your complete system, I think it makes more sense to have like functional tests, like using Behat or Selenium 2 or whatever, that actually just go clicking through your application and does stuff like that. I mean, then you're testing like the functional workings of your website. As I said, I never found the need for it. But again, if you want to do it, there is information on the PHPUnit website on how to do it. There are solutions for that to test it. So if you really want to, you can.
Yeah, thanks.
Okay. Wow. A big one. It's
this one's following on from the database question.
Yeah.
I had a problem recently where I was building a system which had a login system. And I was migrating old data where all the email addresses weren't unique, whereas I expected them to be unique. So this basically caused the login system to not work. So in that case, I would like to test the database.
Yeah, of course. And there are examples, of course. So yeah, again, if you want to test it, I mean, there's a way. Problem is, if you would test it with your with like a test database, so start off with an empty database and fill it with predefined data set, which you would probably do if you would write tests, then that probably would possibly also not been discovered, as it was not in the data in that case. So it's true there still might be problems that aren't like covered by your unit test. That still can happen. On the other hand, the server might be on fire and it won't detect that either, you know. So if you want to push it that far, I really believe that unit testing is about testing the logic of your program, and not as much as everything that's connected to it. But again, if you want to test it, you could. There are possibilities for that. So, sorry. Very quickly, one last question. Okay, I see a lot of hands. The man here in the front.
For each function, each method, is it better to have one test or multiple tests?
So, yeah. So I think it kind of depends. I mean, if you have just a really simple method that you can just hit one time and then you've got it all covered, then probably one test will suffice. But maybe you want to test multiple occasions. I can imagine we have methods where we're calculating like discounts or stuff like that, or taxes, or things that have to do with calculations. So we might write like 50 tests on one method, you know. So just does it behave correctly with negative numbers, positives, with really big numbers, with really small ones, just to have every really weird situation covered to see if it's working. So the answer is, I think it depends what you want to test and how the method that you want to test looks like. So I believe that's it then.
Thank you very much.
Okay.
Harrie?
Thank you. I wanted to add one more thing. Please go to Joined In and rate my talk, and also from the other speakers. It's the first time that I'm doing this talk, so I'm really anxious to know how you liked it, if it was a good idea, bad idea, what I could have done better. So please go Joined In and let me know what you think. Thanks.